which involves an incline, the first thing to do when you're trying to solve a problem which involves an incline, like in this case, when you're pushing a box on an incline, the first thing to do is you need directions. You need to know which direction is going to be positive. Sorry, which direction is going to be the x direction. You need to know which direction is going to be the it's going to be the y direction. So in this case, just a minute. Hello. Zakutumira first. Zakutumira. So in this direction, in this case, we choose a direction parallel to the incline. This becomes our x direction. So this was already done, okay? And since the box, when it's pushed by this 450 newtons, it moves upwards. We choose this up direction to be the positive x direction. Then we choose this down direction to be the negative x direction, like that. So this direction, this box is wrong, so I need to remove that. Need to comment it out. Okay. So that's what we get. So we know that the box is moving upwards with an acceleration of 0.7 meters per second. So basically, we are saying that we choose the direction in which the box is moving to be the positive x-axis, x direction, and the opposite direction, this opposite direction, to be the negative x direction. That. The other thing about after you have chosen the x direction is you need to choose the y direction. So the y direction itself, we choose the y direction to be at 90 degrees with the incline. Basically, the y direction should make, or the y axis should make an angle of 90 degrees with the incline. Okay, that is going to be our y direction. And furthermore, so which is this one, this, it makes an angle of 90 degrees with the incline. So that is our y direction, like that. Furthermore, since that's our y direction, we need to have an idea of which one is going to be our positive y direction and what's going to be our negative y direction. So we need these. If you choose, fine, this is going to be my y direction, then you need to tell us which side of this y direction is going to be positive and which side is going to be negative. So in our case, we choose the y direction above the incline, the part of the y direction above this part above the incline to be our positive y direction. Then we choose the y direction. If this is our positive y direction, then the part below the incline is going to be our negative y direction. So that's the first order of business, choosing directions on an incline. Which part is going to be the x direction, which part is going to be the positive x direction, which part is going to be the negative x direction, which part is going to be, which direction is going to be the y direction, which one is going to be the positive y direction, and which one is going to be the negative y direction. Okay, with those directions, okay, so this is where now some of the mistake came in. Now, you notice one thing here. If this is our y direction, if this is our y direction, this, and if this is our x direction, we have got two forces here. There is this force, the 450 Newton force. There's also the weight of the box. The weight of the box points down. So what do you see? You see that in this case, this force, the 450 Newton force, neither points completely in the x direction, it neither points completely in the y direction. Okay? The 450 Newton force does not completely point in the x direction, it does not completely point in the y direction. there is a part of this force, the 450 newtons, which lies along the positive x-axis. There is a part of this force which lies along the negative x-axis, the negative y-axis. So this force, this 450 Newton force, has got components. It has got an x component, it has got a y component. The if you get this force, this, you shift it to here, you shift it, then you put it here, you put it there. So you see that it has got a y component, an x component, which is positive. It also has got an x component, which is going to be, it has got an x component, which is positive. Then it also has a y component, which is negative. That's the first thing to notice. The same thing applies with the weight of the box. The weight of the box neither completely lies in the y direction nor in the x direction. There is a part of this weight which lies along the y direction. There's a part of the weight of the box which lies along the x direction. So both of these, the force, the pushing force, and the weight of the box, both of them have a component which lies along the x direction and along the y direction. Is that clear? Are we clear about the fact that this force, 450 newtons, and this weight, W, they don't completely point either in the x direction or in the y direction? Is that clear to anyone to see? I need responses. Hello, is there a response? We are having a tutorial. If I ask a question, I need a response. If there is no response, there's nothing I'm doing here. If you just came here to come and get answers, you don't want to participate, then there is nothing you're getting. I'm asking a question. Is it clear to everyone that this force, the 450 Newton force, and this weight, they don't completely point in the x direction or in the y direction which you have chosen?
Yes.
Okay, so which means that we need to find components of these forces. So here, the 400, we notice that the pushing force 450 newtons. So here we have to change this. Lies neither in the x direction, lies neither in the x direction nor in the y direction. In the y direction. There is an x component, of the pushing force that lies or that points that points in the positive x direction, and there is a y component of this force, of the pushing force, that points in the negative y axis, y direction, in the negative y direction. Okay. We denote the x component, of the pushing force as fx, and the y component, of the pushing force as Fy. So this is basically what you're saying. Say this pushing force, the 450 newtons force, does not completely point along the x direction. It does not completely point along the y direction, but it has got components which you're calling fx, the x component of the force. It also has the component Fy, the y component of the force. The x component of the force, as you can see from this diagram, the x component of the force is going to lie like that. So the x component of the force is going to be along this direction. The y component of the force is going to be pointing down. So there's going to be a part of this force which is pointing down along this direction, like that. So if you get this force, then you shift it down like this, then you put it here, so you're going to have like that. So basically what you do is you reproduce this. So in that case, so basically that's what you have. So in this case, the x component, next we get, if I'm not mistaken, fx. Get fx as unless fx is equals to f, I think it's going to be cos. Semina. If fx cos 45 degrees, so the x component of this force, the pushing force, is going to be F cos 45 degrees, which is it clear to everyone why it's F cos 45 degrees? How much does this give you? 450 newtons times cos 45 degrees. How much do we get? 318. We get 318. 318 points what? Point 2? So that is fx. This 318.2 pointing along the positive x-axis. So we get fx which points points along the positive x-axis, x direction, positive x direction. Starts.
We started off.
Okay.
Sure. See us in no direction.
Alright, cheers. So next we have to get Fy. So next we get Fy. So next we get Fy, which points along the negative y direction. This is going to be f sine 45. Sine 45, which again is going to be the same. Is that clear?
Yes.
Okay. The next thing, this one remains. Since the box moves upwards, right, there is friction force that opposes the upward motion of the box on the incline. The friction force lies in the negative x direction. Okay. However, the weight of the box, so there is the weight of the box. However, the weight of the box, which always points down, lies neither in the x direction nor in the y direction. So if you look at the weight of the box, this weight of the box, it lies neither in the x direction or in the y direction. Okay, so we have to find its components. However, there is some part of the weight of the box which lies along the x direction and also in the y direction. These parts of the weights which lie in a specific direction, either the x direction or the y direction, this is what we're calling the components of the weights. And there are two of these, the components of the weight. There is Wx, the component of the weight which lies along the incline. There is Wy, the component of the weight which lies perpendicular to the incline. So there is the component of the weight which lies along this line, the y direction, which is perpendicular. There's a component of the weight which lies along the incline. Now, when you're looking at the weight like this, another thing of interest is the angle of the incline. The angle of the incline and the angle here, they are the same. It's 45. Okay? So, for the y part of the weight, for you to find the y part of the weight, you have to do the y part, the y axis, the y component is going to be the weight of the box, then cos 45, that's the y part. Then for the x part, which is this side, which lies this side, it's going to be the weight of the box times sine 45. So in this case, when you're dealing with an incline, the components change. When you're dealing with an incline, the components change. So you end up having wy is equals to w cos 45, and I think in this case this thing can actually be worked out. We don't have to wait a lot. So that is going to be also equals to md cos 45, like that. Are we clear about the weight? Why it is w cos 45? The wy and why wx is w sin 45? Are we clear about the weight? Hello?
Come again on that one.
Here, this is a weight of the box. The weight of anything points down. Do we agree?
Yes.
However, as you can see, this is our y direction. This is our y direction. And this is our x direction. Okay? Parallel to the incline, that is our x direction. Perpendicular to the incline, that is our y direction. So the weight of the box neither points completely in the y direction nor in the x direction. Do you agree with that?
Yes.
So if that's the case, it means that the weight of the box has got components. It has got a y component which lies along this line, which is wy. It also has an x component which lies along this line. Since the weight is in this quadrant here, it means that the x component should be this side. Then the y component should be like that, down like that. The other thing is the angle. The angle between the weight and the y direction. This angle. Have you seen this angle? The angle between the weight and the direction of the weight and the y direction. This angle here. You've seen this?
Yes.
This angle is the same as the angle of the incline. Is that clear?
Yes.
The angle of the incline is 45. The angle between the weight and the y direction, this angle is 45 degrees also. So if this angle is 45 degrees, then the y component is going to be w cos 45 degrees. The x component, which is going to be the opposite here, is going to be w sin 45 degrees. Is that clear?
Yes, sir.
Okay. Which is what we are trying to do here. So the w, the mass of the box is 20 kgs. Then the acceleration due to gravity is 9.8. So you're going to work that out there. So this needs to be worked out. So we're going to have 20. RM 20 kgs. 9.8. Meters per second. How much do we get? 20 times 9.8 times cos 45 degrees. How much you get?
138.59.
138. So we get 138.59, basically 138.6. Newtons. So that's what we get as WY. This WY is pointing in the negative Y direction. Where is it? So this WY Y points in the negative Y direction. Is that clear about this? That WY is pointing in the negative Y direction? This side?
Yes.
Okay, so we move on to find WX. WX is pointing in the negative X direction. We find the X component of the weight. So the X component of the weight is going to be, how are we going to find it? So similarly also, we're going to have these bits, but now we're going to have sine. We're going to have that. So we're going to have this W sine 45, then mg sine 45 like that. And that's going to give us negative X direction. It's going to be the same. The answer is going to be the same, because sine 45 and cos 45 basically give you the same answer. Oh, sorry. It's supposed to be W here. X. Here. So WX is also equals to this. So, what do we have? We have WY pointing the negative X direction, WX pointing the negative WY pointing the negative Y direction, WX pointing the negative X direction. We have got the friction force pointing the negative X direction. We have got FX pointing the positive X direction. We've got FY pointing in the negative Y direction. Okay, so basically that's what we have. So when we reach here, so we say so we have the following forces. We have the following forces and their directions. The directions as follows. So begin. So the first one is the friction force, FF. FF is pointing in the negative X direction. Negative X direction. Next, we have another force pointing in the negative X direction is WX. WX is also pointing in the negative X direction. x direction. Then we have item fx, the force fx, component of the fx is pointing in the positive x direction. So basically this is what we're trying to say here. The friction force is pointing in the negative x direction, Wx is also pointing in the negative x direction, Fx is pointing in the positive x direction. Then we come to Fy, item, Fy is pointing in the negative y direction, and the other one pointing in the negative y direction is wy is also pointing in the negative y direction. So what do we see? Where are we? Here. So what do we see? We have two forces. This Fy and Wy. We have got two forces pointing in the negative x direction. We have got two forces pointing in the negative. Sorry, we have got two forces pointing in the negative. These ones, y direction. We have got two forces pointing in the negative x direction. You have got one force pointing in the positive x direction. But at the moment, we do not have a force pointing in the positive y direction. Okay. So these two forces, Fy and Wy, pointing in the negative y direction, they exert a force on the incline. Is that clear? This one, Ff and Fy, they apply a force on the incline. Is that clear? So we notice two forces, Wy and Fy, that lie, that point in the negative y direction, and therefore exert a force on the incline. The incline will not be happy with the force exerted by these two forces, Wy and Fy. Therefore pushes back, exerts and pushes back on the box with normal force Fn. This normal force lies in the positive y direction. According to Newton's third law of motion, the reaction force must be equal and opposite to the action force, but opposite direction. This is so because we do not see the box flying off. Therefore, you conclude. So we conclude that the normal force is equal to the two forces which are acting in the negative y direction. Is this clear? This is the conclusion we make. Are we clear here about this?
Yes.
Okay, since we already know FY we found FY to be this. This is our FY. Then we also have this one. We can find the normal force. Substituting. We get the normal force. As again, let's copy. So WY is where? This is WY. That is WY. Then FY is there. FY. And this gives us how much? How much do you get for the normal force? 163.6 plus 381.2. How much do you get? One 63.6 plus 318.45 something. 454.8. Can someone confirm that?
It's correct.
What have I done? Okay, so this is what we get for our normal force. Okay, so we are done with the y direction. So our interest now, so here, if we look in the x component of the weight, we already have that. So we notice what? If we look at the x component of the weight, which is the PA, we see that it lies along the negative x direction. Yes, we know that. Therefore, we notice that there are two forces, Wx and FF, that point in the negative x direction, and one force, the one force pointing in the positive x direction is now where is that? Fx. One force. So these two forces, Wx and FF, they point in the negative x direction. We have agreed on that here. This negative x direction. This negative x direction. This one positive x direction. Therefore, we can get a resultant force in the x direction. So the resultant force in the x direction, this is going to be, in the x direction is going to be, the resultant force is going to be what? So I need to, how do I distinguish fx? Maybe I need to write capital X. I think, yeah, I might need to write capital X. Let's see how that looks. Okay, yeah, so in the x direction, this is what we got. So we have fx, positive, minus fy. So these are negative, this is negative. They point in the negative direction, this one is pointing in the positive x direction. So we end up having fx minus this and that. Then we have this much. We know this much. We know fx. Fx is, we found it. Fx is this one. We also know this. Wx. Wx was found, I believe, here. So the only thing we do not know is so much about is the friction, but from the friction, that's something which you can do. Okay, so that's now here from Newton's second law. So we have, why do we need this? We need this because we need to use it in Newton's second law of motion. Okay, so in Newton's second law of motion, in our case, because of the notation, we have to write capital X here, then the acceleration in the X. So we're going to have fx, then that, which is okay. Yeah, so we're going to have these. The resultant force in the x direction, which is what you have here, that is equals to some fx, then minus the friction force, then that. So in our case, we have this, that, this, then that. Then there's also a small fx missing here. So next, there's an fx missing there. There's an fx minus ff minus fw, like that. So these ones we know. Okay, so we don't have to worry about them for now. However, the only thing we do not know so much about is this, the friction force. Up to here, are we clear? Are we clear up to this point? This is the mass, 20 kgs. The other one is the acceleration in the x direction. That we have already been given. It's that. Since the box is going to be moving, so the kind of friction it has is kinetic friction. So the friction force is going to be the coefficient of kinetic friction times the normal force. Remember that we have also found out what the normal force is already. So in our case, the normal force, in our case, we have the recall that the normal force is equals to this. That. This is the normal force. So we recall that, okay, and the normal force is equal to that, which is equal to this, kind of that. So here we have this, then we substitute this we have worked out already, so I delete this stuff. So Wx is this, Wy is that. What do we need? Wx, that. Then there's Fx, then Fx, Fx. We don't need Wy anymore. And then which one is it? the fx. Just a minute. Fx. Okay. So here you have that. Then here you have 450. Then that's the side. Okay, so what do we have? So let's get us. So here, so this, the friction force, we kind of know the friction coefficient, then the normal force. But we know the normal force is equal to this. So we end up having the friction force as the coefficient times the normal force, like that. So we substitute the friction force with this expression of which we have there. Then Wx is this. That's Wx. We know that. Then Fx is that, which is that. So we know that. So we substitute here for Fx, then minus the friction part, then that. Then next we do 318 minus 138.6. How much is this? 318.2. So 318.2 minus 138.6. I have 179.6. Is that what you have?
Yes.
Okay. 179.6. Then again 179.6. Okay, so I have 179.6 newtons minus mu k, then this one here, 4 something. Where is that? This, the normal force. Normal force. Normal force. Normal force. Okay, so I have this one. So 179.6 newtons minus nu k 454.8 newtons equals to 14. So we get this 14 newtons, we take it the other side, and then we get this negative coefficient thing, we take it the other side. So we end up having this expression, this, and that side. How much do you get for this? 179.6 newtons minus 14.
165.6.
165.6. So you end up having 165.6 newtons. Newtons. Doing some changes there. Okay, so I have 165.6 newtons equals to nu k 454.8 newtons. Then I divide the 165.6 newtons by 454 newtons. How much do I get? Because I want to find mu k.
0.364.
0. 0.364. And as you can see, that is our answer. You have your tutorial sheet nearby you?
Come again?
Do you have a tutorial sheet near that? So, because the tutorial sheet has got what the answer is supposed to look like, right?
I'm not having it with me right now.
Okay, so the one I have, it's showing that the answer is actually 0.363 or 364. It's the same. Is that clear?
Yes.
Yes. So, what exactly did we do? And how did we do this? We started like you're supposed to do when you're looking at an incline problem. The first thing we did is choose directions. You have to choose directions. Normally we choose the direction perpendicular to the incline, parallel to the incline to be our parallel to the incline to be our x direction. Then after you choose the x direction, the other thing we normally do is you choose the direction in which the box is moving to be the positive x direction. Since the box is being pushed up, we chose that to be our positive x direction. Then the opposite direction of that became the negative x direction. The other thing is you have to choose the y direction, and normally that's chosen to be perpendicular to the incline, because the x direction and the y direction, they have to be at 90 degrees to each other. Okay. Then after choosing the y direction and the x direction, then we have chosen to say the direction in which the box is moving is our positive x direction. Then the opposite direction is the negative x direction. We choose the y direction above the incline to be the positive y, and the one below the incline to be the negative y. Okay. With this choice of direction done, we clearly see that the weight of the box, W, and this pushing force, this F, pushing force, these two forces, they do not completely lie in the x direction or in the y direction, but some parts of them lie in the x direction, some part of them lie in the y direction. So we proceeded to find those. We proceeded to find Fx. If you get Fx, then you bring it here. You can see that Fx actually like that. So there's a part of Fx which lies along the x. There's a part of it lying along the y direction here. So we proceeded to find Fx, and this is what we did. Fx, we found that. Then we also found Fy. We found that. Then the other thing we noticed is if the box is going to move up, then the friction has to be opposite. So the friction actually lies in the negative x direction. Then we moved on to the weight of the box. The weight of the box lies neither in the y direction or in the x direction, but some bits and parts and pieces of it lie in the y, the other bit lies in the x. The angle between the weight and the y direction, that angle is the same as the angle of the incline, 45 degrees, 45 degrees. So we proceeded to find Wy and Wx. We noticed that Wy lies along the negative y direction, Wx lies along the negative x direction, and we found them, which is what we did here. Wy is equals to W cos 45, mg cos 45, and that's what we found here. Then Wx is equals to W sin 45, and that's what we found here. So we took note of the forces we had so far and the directions in which they're pointing. So we noticed that Fy, the y component of the pushing force, and the y component of the weight were actually pointing in the y direction. So they were exerting a force on the incline. If they were exerting on the force on the incline, if you push something, you apply a force on something, definitely whatever it is you're putting a force on is not going to be happy. So the incline was not happy. But what did the incline do? The incline exerted a reaction force, which is the normal force. And since the box was not flying off the incline, it means that the incline exerted a reaction force which is equal but opposite to the forces being applied in the negative y direction. The two forces acting in the negative y direction were this Fy and Wy. These are the ones. So the reaction force or the normal force has to be equal to these two forces. And that's how we proceeded to find this normal force. So we were done with the y direction. Then we moved on to the x direction. In the x direction, we noticed in the x direction, say, there is the friction force. It's pointing in the negative x direction. There is Wx is pointing in the negative x direction. There is this Fx. This one is pointing in the positive x direction. Therefore, the resultant force in the x direction is the component, x component of the pushing force, plus this friction force which is negative, and this which is negative, and we ended up with this. We know how much Fx is, we know how much Wx is, and we put them like this. So we decided to apply Newton's second law of motion in the x direction, and that's how we ended up with this here. The mass of the box and the acceleration of the box, and that gave us the 14 newtons. Then we have this. So this is a resultant force. So here there was no problem with the Fx because we already knew it. The Fw, we already knew it. The only problem was with the friction. And if you've got friction of a body which is moving, this is how you find it. The friction force is equal to coefficient of friction times the normal force. We had already found the normal force up here, there. So we substituted. The friction force became the coefficient times the normal force. We substituted there. Then after that, we proceeded to substitute these other values which we already had. This and that. Then we added these. We got that and this. Then we proceeded to manipulate this until we came up with a value of k, mu k, which is that. Okay, is that clear? Are we clear?
Yes.
Okay, so we're going to stop here. So I'll proceed to upload the solution to Moodle, and also I'll upload the video to YouTube. All right.
All right.
Yeah, have a good night.
Good night.
Yeah.